Glad you're here. If you are a regular webinar attendee, then you've heard this before, but we have so many new folks joining that I like to level set. And if you're signing up for these webinars, then that means that you want to get more done, you want to move faster and produce higher quality so that you can deliver for your team, for your company, and for your customers. And so again, this series is the second to last one of this series, .NET DevOps for Architects. We're at week number 6 out of 7. And this is aimed at software leaders who want to enable their teams to be world-class and deliver world-class results. So all over the industry, software projects are hard, but yours doesn't have to be. If you don't change anything, then nothing's going to change. So we have that to keep in mind. But I understand that you're probably dealing with delays, with quality problems, and tons of complicated choices in developing and growing or changing your software systems. And we like to simplify that process and empower you to deliver world-class results, to move fast, to deliver quality, and to run your systems with confidence. In this day and age, everyone expects software projects to have delays. And our process helps development teams get projects done on time. Everyone also expects bugs. There's a reason why people don't launch software on a weekday morning. Our process improves quality, and everyone expects to have to babysit their software as it's being used in production, but our process empowers teams to run their systems with an increased confidence. And we've had a positive impact on over 100,000 developers in over 40 countries so far. And we're enabling more and more development teams to deliver for their organizations every day. Now, I want to give you a little bit of encouragement. Just by you studying and attending this webinar, I know that you, my friend, you have what it takes. You can do it. All you need is the right process and the right tool belt. You have what it takes. I know from experience that if you map out your software delivery process and then automate it, you will deliver more, and you and your team will absolutely love the results. So let's dig in. Last week, we had an overview of release management in general and sequence of environments. And I'll review a few items of those, but we're going to go through the common mistakes that people make when trying to put in place automated deployments and even deployments in general. And then 3 critical elements of how you should do automated deployments the right way. And then I'll give you some tips for getting started. Now, a few logistics. We have the Q&A window in the Zoom software. If you have a question during the webinar, then put a question in the Q&A window, and then I'll make sure to work that answer in during the webinar. And my commitment to you is that I won't close the webinar without having answered all the questions. And every week I'm super excited about the tremendous audience, and humbled that all of you find this of value. But I do want to give you something of tangible value now to help you get automated. I don't want you to continue to be frustrated and sometimes trapped by the software that you work on, that software that always seems to find a way to break upon deployment. And I do understand the lost weekends and sometimes surprise overtime due to software builds and deployments when they go poorly. So here's what I want to do, and this is what I need you to do. Step 1, you need to read my book. And by the way, I will give you an ebook copy for free just for being here today. Just send me an email and I'll get it to you. And whether you are watching live or, by the way, if you received this recording from a coworker, that goes for you too. Just send me an email. I'd be happy to equip you with that. And then number 2, read the book and understand the 7 stages of a DevOps pipeline. And that's in the book. And then number 3, launch your .NET DevOps pipeline. Use our public project as a model. You'll find that project in the book. And if you do this, you'll have a fully automated DevOps pipeline using Azure that'll enable you to move faster and deliver higher quality. Now, I just literally a few days ago, I just taught our 2-day .NET DevOps bootcamp here in Austin. And we have another one on the schedule in January of 2020. So just go to our website and sign up for the next class, which is right at the beginning of the new year. And it's an immersive, hands-on boot camp style training class. Every student came away with a completely automated DevOps pipeline with their own Azure DevOps Services project, the source control structure of their application, and they walked away with it with a complete environment, soup to nuts, including telemetry, hands-off automated deployments. Also, if you are going to the Ignite conference next week, catch me there. I'm one of the official conference reporters reporting on all the development stuff. And this Sunday is the official launch of the production ready A-Press published version of my book, .NET DevOps for Azure. You can go on Amazon and you can find it. And then my email address is right there on the screen. Take note of it. Also, if you are not a subscriber to the podcast, you will want to make sure to get on the Azure DevOps Podcast. Go to any of the podcast directories or just to azuredevops.show and subscribe to the podcast using whatever type of smartphone that you happen to use, or even listen straight there on the computer. Now, our agenda for today is automated deployments. We are in week number 6 of 7 of our webinar series. And so let's just dig right into the common mistakes. I want to be respectful of your time and dig into this information and get through it. So there's a few common mistakes people make. And the first one is deploying from an environment branch. We see it all the time where there is a branch called QA or a branch called staging. And when it's time to go to production, the code that's on that branch is built and then deployed to production. That's a big mistake. It leaves so much surface area open for something to be left out of the code, and then building and packaging up what is on that branch and then going to production. What actually goes to production is not guaranteed to be what was approved to go to production, because we're going all the way back to the source to get it. The second common mistake is not labeling the release candidates. A lot of times when we work with the development teams, one of the first questions is, what version is currently in a particular environment? And if we're not labeled, if we don't have actual release candidate version numbers, then we don't actually know what's in a particular environment. Another mistake is omitting post-deploy validations. A good sign of this would be if you ever deploy to an environment and then you tell someone in your organization, hey, we just deployed, go ahead and check it out. And they pull it up, and the first time they pull it up, something blows up on them. That's a sign that there's a validation that needed to be done right after you deploy to make sure that the software actually started up properly, was configured properly, and the environment is healthy. The final common mistake is storing environment-specific configuration values in your source control. First of all, if you spin up a new environment, you have to change it there. Secondarily, the architecture level is wrong. The environment owns its specific configuration values, but the fact that a configuration item exists, now architecturally that does belong to the application, but the values, those belong to the environment itself. And we'll go into a little bit about that structure later. So I want to review really quickly the cycle, the process layers of Onion DevOps. And we've been talking a lot about the Onion DevOps model. It is viewing our different cycles as concentric circles, and the inner cycles spin faster. The inner cycle, which is code, we make a code change, we run it locally, we make a code change, we run it locally. We go through that cycle over and over and over and over. And then the team cycle is when we have the code changes from multiple developers, and the team produces a particular build, a particular release candidate, and that is also a cycle. If you're doing Scrum, then your Scrum cycle would be the duration of that. Then the product level cycle is product management, or before you go to production, whoever in the organization is in charge of that particular piece of software and doing the product management, and that is the manual testing cycle. How quick can a change request be made and then it come back and be on some type of pre-production environment so that the product management group can provide feedback on it. And then finally, the customer cycle. Whether a good sign of this is from the time that you start on a feature to the time that it's in the customer's hands, or the customer provides a there's a bug report that made it to production. How fast can we go all the way around that cycle and get it fixed for them? So each layer is a kind of define, do, and then look at the data. And the interior cycles must spin faster. And this maps really closely with a Kanban board, which has stages for all of the different things that need to happen. Development is in the center with code, and then before code is various design decisions at the customer level, the product level, the team level. And then after code, there is validations at the team level, the product level, and the customer level. And so again, some of the questions we're looking for in the code in the center and that quick cycle time is it ready for a pull request? Is it done? Did it deploy and pass all of our full system tests? Do I have all the does it work after back merging from master? Lots of questions. And then on the team side, did we use the patterns and libraries that we said we would? Does all existing functionality still work? Is the pace of delivery adequate? At the product level, does it work properly on different computing devices used by our audience? Can I sell it as it is? Things like that. All right, so 3 essentials to automated deployments. First, we are going to build once, and we are going to deploy what was built many times, okay? Each release candidate is set up as a handful of files, 1 per deployable component. For instance, just review of last week, if your application consists of a web application, some offline job, and a SQL database, then you'll have 4 files that make up your release candidate. One of them will be for each deployable component, and the 4th will be your full system test suite, but we build that once, and it's built at the end of the integration build. It's stored in some type of storage area. If you're using Azure DevOps for everything, then Azure Artifacts is the place to store them, and NuGet is the format to store them in. Now, if you have a legacy system and it's just not going to work well with NuGet, a zip file will do just fine. In fact, if you rename the .nupkeg extension of a NuGet package to .zip, you can actually unzip it. It literally is the internal format of a zip file, okay? But we're going to build once, deployed many. That way, in any number of environments, when that particular version, when that particular release candidate is approved to go to production, then we know that what we are about to deploy to production, that exact thing is what was tested. If we go back to source, if we go back to a branch and then go to production, we don't have that level of guarantee because what we're going to build and then package didn't actually go through all the different environments. The second essential is a post-deploy health check, and we'll show an example of it in just a second. But a post-deploy health check is essentially giving the application responsibility for reporting that it has started up, it's online, and that it is ready to go. Far too many times, we will configure a tool to copy files and poke a configuration file with some values and start a service, and then you will just declare that the deployment was successful. Well, that's not a deployment. Those are steps in a deployment, but a deployment is successful when the new version of the application is stable, up and running, and is ready for actual usage. And so in order to answer that question, we need to verify that it's ready to accept transactions, that it's ready to accept real usage. And architecturally, the area that is going to give us the best answer is the application itself. And so we want to ask the application, are you running and are you online? And we'll talk about that a little bit more. Also, we want the deployment to be a one-click process, or automatically triggered and no clicks. We don't want to have to do any manual steps. We want it to be repeatable. And at worst, clicking an approve button to say go. That's it. We want it to be absolutely one click. That includes tweaking anything about the environment, configuration files, pushing in credentials and passwords from the right storage area, laying down files, everything. We want it to be 100% automated. Okay. Now, let's reflect. Let's just reflect on some of the past deployments. When was your last challenged deployment? How did it make you feel when that happened? Do you remember the stress welling up in your body when you realized that this wasn't going well? And then invariably you had some type of conversation after the fact, but do you have complete confidence that your next deployment will go as planned? And why? It's important that we equip ourselves with the ability to answer yes to that question. Now, this is the flow of build once, deploy many. The integration build is going to finish up by packaging up the deployable components with everything that needs to be there, including perhaps some PowerShell scripts that tweak the environment. We're going to push that into Azure Artifacts, and then the automated deployment routine for each of our 3 unique environment types goes to Azure Artifacts to get the NuGet packages that make up the release candidate. Now, I've said it before, but if you weren't in the previous webinar, there are 3 unique types of environments, and you need at least one of each. So no DevOps pipeline will ever have fewer than 3 environments. Production, everybody knows you need at least one. Some teams have multiple production environments. If you're deploying an instance of your application to each individual customer, you're going to have more than one production environment. Backing off from production, we need a manual test environment. I've called it what's probably one of the most common terms, which is the UAT environment. It is an example of a manual test environment. You need at least one, but a lot of organizations will have several, and that's great. There's a lot of names for manual test environments: dev, test, QA, UAT, staging, integration. There's so many names that people have for a manual test environment, but it is a single environment type, manual. Okay. And then the third environment type we find missing in a lot of places, and that is the automated test environment, or the test automation environment. No humans are allowed in this environment. This environment exists to complete the commit stage of continuous integration. And if you have not read the book, Continuous Integration, that was published by Addison Wesley back in 2006, I'd highly recommend that you read the book. I find that a lot of people say that they're doing continuous integration, but all they did was listen to one of the tool vendors and have an automatically triggered compile process off of source control. Compiling code is a step in continuous integration, but automatically compiling your code is not continuous integration. That does nothing to make sure that code and changes from various sources actually renders a stable application. Okay. So the final step in the commit stage of continuous integration is to actually deploy the new version and make sure that it starts up. We do that in the TDD environment, and that's my name for it. It stands for test driven development. Let's give it an environment name. Let's have automated tests, automated verification after we deploy, to make sure that the changes that were just made don't destabilize the application. So there's 2 things. We need to make sure that it starts up, and we need to make sure that everything that was working still works. And then once that's done, the TDD environment can be destroyed. It can go away. And if you're using cloud services or even command lines on VMware, it's an easy command line to destroy that environment, and then you can recreate the next one the next time you do it. And that's pretty common with the TDD environment. Also, full system tests that we talked about last week, full system tests go here. And in the web application world, Selenium is a common tool. And if you're doing Scrum acceptance criteria, then Full system tests are the perfect executable implementation of that acceptance criteria, depending on how many scenarios you need. All right, just a quick review before we go through deployment on how a example application is structured. If we have a website, an offline job, and a SQL Server database, each of those has to be deployed as a separately running process. And so we have a NuGet package for each. And then our full system acceptance tests also have a NuGet package and a version, because a particular version of that test suite goes with a particular version of the application. And then from a sequencing of our pipeline, we are going to have the TDD environment, the UAT environment, and production. Again, you will never have fewer than 3 environments in any DevOps pipeline. And we're going to automatically trigger that from the integration build. And of course, after we run it, we are going to see that 100% of the tests passed in the TDD environment. That's our goal. Or if 100% of the tests don't pass, that stage fails and we don't even bother going to UAT, because that release candidate will never see the light of day because something's wrong with it. Now, as we go across the different environment types, it's a little bit of review. There's a purpose and audience and different quality control steps that we assign to each of the environment types. Okay. But for automated deployments, let's go through the routine for automated deployments. So this is a quick screenshot of Azure Pipeline's release management, release manager. This is a deployment, and this process is in the edit screen. And you can see that we are doing something with the database package, and we're doing something with the UI package. Now, at the beginning of the sequencing of steps for doing a deployment, we want to tell Application Insights that we are doing a release, because if some of our metrics start going sideways or some of our users start reporting problems, we want to be able to clearly see, oh, shoot, that started happening right after we deployed version such and such. And so adding a release annotation gives that to us. Now there's a pattern that we go through depending on how many deployable components we have in our application. So this is just abbreviated. If all we have is a database and a website, then we have 2 sections here. And each section starts with obtaining the release candidate deployable package, obtaining the package from Azure Artifacts. And in this case, we start with the database. And then the next thing we do is we configure the environment. Now, if we're using infrastructure as code, configuring the environment means creating the environment. But at a minimum, we are making changes to an environment that's already there if we're not automatically recreating it. And that includes poking values into configuration files, configuring different things. And after we've done that, then we can actually do our deployment. In this particular example, we deploy the database schema using that PowerShell task, create database schema. And we're using a database migrations tool to create the SQL files to run the SQL files that had not yet been run on that target database environment. And so that's a 1, 2, 3 punch for deploying the database. The next step is the UI package. This is an ASP.NET application. And so we obtain the deployable package from Azure Artifacts in the obtain UI package step. And then we need to configure the environment. With Azure PaaS, in this case, we are either creating the website, creating the app service, or modifying it. And the implementation of this happens to be the Azure Resource Manager files. So the ARM template is going to deploy it if it doesn't find it, if it's going to create it. If it does find it, it's going to make sure that the settings match. But either way, we are configuring the environment. And that includes punching in the connection string and any other variable values that may be there. And then we do our actual deployment. Now, sometimes a deployment step will automatically including starting the service, and sometimes you have to set that as an explicit step. But either way, for the purposes of this pattern, when I say deploy something, deploying ends with it's actually started. It's actually started up and running. So we obtain the package, we configure the environment, and then we deploy that particular process. And once it's up and running, then it's it's deployed, it's started. Now, after this completes, and if you have 3 different Windows services or whatever other components your application has, you'll repeat this for each deployable process, okay? After this completes, you want to do something else before you let your tool tell you that the deployment was successful. You want to run a health check. And this is a little PowerShell that can do it against a web application. All we have to do is check a URL. And in this case, it is /healthcheck on line number 2. And it's easily implemented. If it's ASP.NET, you can just create a controller called health check. And all it does is tickle the various parts of the application that need to be checked in order for the application to be healthy. Now, what if one of the pages in your application comes back, but another page completely blows up because the database connection string is wrong, or the database is not online, or some other dependency that the application has is not functioning properly? Then the application is not online and the application is not healthy. Okay, so how do we get that answer? Well, whatever the health check controller is in this example, if it's ASP.NET's the head of the application, we don't just have it come back with, oh, success. We want to send some simple query to the database, because if the database connection string is wrong or the database is not online, we want that to fail so that we can return the message that, no, this application is not online. This application is not healthy. And if we have a dependency on, let's say, one of the credit union's, credit bureau's web services, well, let's call that web service, just do a really simple read operation, just a ping operation essentially, because if we can't get to that web service, we are not online. We are not healthy. So you see the pattern here. Every application has dependencies that have to be connected, online, and healthy in order for the application as a whole to be healthy. So that's what it means to have a health check. We're not checking to make sure that the web server is running. We want to make sure that the whole application is healthy, is ready to be used. And so we need that, whatever that endpoint is, to just do a quick check to crawl and ping all of the dependencies that the application has. So if one of them is broken, we know right away, and we can report back, the application can report back, no, I'm not healthy. And then our tool receives the message, oh, this deployment did not work right because the result was not an application that was online ready to be used. And then we fail the deployment and we have a really early warning as opposed to the deployment succeeding. Maybe we go to one page that only checks to see if IIS can serve a static page. And then we tell other people in our organization, hey, build number such and such is ready for you to start testing. And they just click through 1 or 2 screens and it blows up on them. And now we've wasted their time. And we then have to jump back in and try to figure out what's happening versus us having a real good early warning signal that we've got a problem here. Now, what's interesting is because continuous integration does include one deployment, we are going to find this thing out before we even declare that we have a viable release candidate. And we're going to find this out on our feature branches before we even merge code in with a pull request to master. So this is a powerful concept. So let's review the essentials. So the first essential is to build once, deploy many. Don't go back to source control. Label a release candidate with a version number, and you'll have some number of NuGet packages that make up a particular versioned release candidate. And you have that handful of files, okay? Next, do your post-deploy health check. Make sure that you don't declare that a deployment was successful unless the application reports that it is started and it is healthy. And make sure that health includes all of the dependencies that the application has. And then third, make sure that it is a one-click deployment, that you grab the appropriate release candidate package, that you configure the environment, and that you deploy the appropriate files and start it up, and make sure that all of that is automated. Don't leave any manual steps in place. All right, so next week we are going to be talking about telemetry and how to observe exactly what is going on in your application. And next steps for you, remember, send me an email so that I can send you a free copy of my book. And as you read the book, use the included Azure DevOps Services project template and literally get up and running within a day. And we are just about finished with an automated getting started template that will get you that will get you up and running with your project in about 30 minutes. And if you are interested in that, if you're building a new application or getting a DevOps environment up and running with one of your existing applications, send me an email if you're at that stage, if you're interested, because we are just about ready with a 30-minute process that puts all of this in place for you in Azure DevOps Services. Also, be sure to subscribe to my podcast. And next week, tune in as we dive into how to implement telemetry and how to gain the ability to observe exactly what your software is doing all the time. All right. And as usual, go to our public example project, bit.ly/.NET DevOps project. And thank you so much for being with me today. I think I was able to answer the questions in line as we flowed through. Thank you for your attention, and I hope you guys have a great day.